All right. Hey, everyone. Welcome to my awesome talk. As I was just introduced, my name is Ashley Williams, but you may know me as AG Dubs from the internet, and if you do, I am sorry. But I do not have a lot of time, and I've got a lot of content, so let's just jump right into it. What is this talk about? This talk is about a couple of things. The first thing it is about is performance. But more importantly, performance that makes things more accessible. And unlike a lot of the talks that we've seen at this conference, this talk is also about infrastructure. Can I get a shout out from any of the ops people in the room? Come on. Who's on pager duty right now? All right, someone. I'm so sorry, that sucks. But in a general thing, I also want this talk to be a little bit about how the internet works and potentially how the internet could work. And so this talk is called JavaScript's Journey to the Edge. And so there's a little bit of journeying as well. Perhaps you're more familiar with this Journeys, if you're from the United States. But I wanted to say just a small thing, as this is JSConf's at least last for the moment talk, about how important this conference has been to me. First off, I spoke at the last Reject.js in 2015, and I was the second to last reject, only to Mariko, who was the last reject. And it was one of the most amazing conferences. The next day, I went to JSConf EU and promptly saw someone wearing a shirt with my face on it, which was a fascinating surprise. And this was from a musical number they had done using some quotes from a previous talk of mine. And they did that again in 2017 or 2016 with the classic People Got Mad, which was an auto-tune of my voice talking about how people get mad if you put all your code in one file. They do get mad. So, but then I spoke at JSConf in 2017, and I wore an Antifa shirt because I thought that was rad, and this is a place you can do that. It was a super fun talk, and man, I have so many friends at this conference. The last time I was here was last year, where I did an impromptu Rust and WebAssembly workshop for about 100 people from the Mozilla booth. And it's cool, because someone published their first NPM package, and it had WebAssembly in it. And so this conference is super awesome, so can we just give it a round of applause? I love this place. But this talk is obviously not about my journey. This talk is about JavaScript's journey. So I'm about to show you some very scientific timelines that I made using Wikipedia and Keynote. So JavaScript has had a really fascinating kind of history, and a lot of people have talked about history because of this being the 10th one and Node being announced in 2009, or 2009. That's fine, you can say it like that. But we've seen a lot of development from JavaScript, and we've seen it develop really, really quickly. And I think it's kind of developed in one particular way. So here we see the first website in 1991, and then we end with WASM up in 2017. By the way, oh my God, WASM was only born in 2017? Amazing. But we also saw the appearance of a fair number of things, including a lot of browser engines and a lot of frameworks. And I think one of the most pivotal things in this this timeline that people don't usually see is that the emergence of Google Maps in 2004 really motivated people to see what you could do inside of a website and made it so that we started developing all of these things so you could do browser computation so much faster. So if we put these graphs together and we take a look at this, what's happening is that the speed of computation in the browser is just exponentially growing. And that is so awesome. And I'm a big WebAssembly fan. I'm super here for this. However, because the browser has become such a computationally awesome agent, we've run into some costs. How much does doing this cost? And fundamentally, this comes back to the idea of accessibility. And it's spelled wrong here, but it really comes down to the fact that what we're talking about is the ability for people to even access content. And so Adi Osmani, in his talk, The Cost of JavaScript in 2018, said, the web is bloated by user experience. And he's genuinely completely right. So how many people here have ever checked out HTTP archive? If you haven't, it is amazing, and you should look at these numbers. This is just one of the graphs, but what this graph is showing is the median size of desktop and mobile applications with the JavaScript bytes that are being downloaded to the device, and we have seen a 353% increase for desktop, and it's worse for mobile, 577% growth in how much we're sending to the browser. And that's cool, because remember, the browser can take that stuff and it can compute it really fast. But moving those bytes over the wire takes a lot of time. And so on average, remember this is on average, there's people who are on the really bad end of this. Mobile loading time for an average website takes 9 seconds. All right? That's unacceptable. And so this is going to be part of the problem we're going to solve in my talk today. So my intro did not entirely say this, but I am a systems engineer for a big orange cloud, not to be confused with a big orange website, which I am not a fan of, or SoundCloud, which has a surprisingly similar logo. I work for this thing called Cloudflare, and I know the cloud doesn't look super big here. It's in perspective, right? So what does Cloudflare do? Cloudflare is an infrastructure company. It turns out Cloudflare is not super good at actually defining what it does, but the thing you definitely don't call it is a DNS company. Because also, I mean, no one likes DNS. I can't ever figure that out. I work at a DNS company now, and DNS, man. But we call ourselves an infrastructure company. And sometimes I describe Cloudflare as a hardware company. And that is because our primary asset is this. And this is a map of 180 data centers and growing all over the world. And so this set of data centers contains something which is called the edge. And this is a terrible name. It doesn't make any sense to most people. Someone said there's a wrestler called the Edge. I don't know who that is, whatever. But to try and talk to you about what the edge is, we're going to talk about one of the classic dichotomies in web programming, client and server. And to do so, let's talk about pizza. Who likes pizza? All right, there we go. I'm originally from New York, so pizza is cool, right? And we're going to talk about pizza delivery. And I want you to view that in the eyes of pizza accessibility, because it would be terrible to deny people pizza, right? Especially warm, fresh pizza, right? So obviously, you got to smoosh those together for pizza accessibility. All one word. All right, so we're going to do some animations here. Here's a small key. Your JavaScript program is going to be represented by this lovely chef. Your JavaScript program executing is the bang emoji. Your JavaScript program's generated output is a pizza. Your end user is a superhero, because this is how we should always think about our users. And we're going to have this interesting thing that's a basket, and so that you can kind of think of that as like a data center, a point of presence, or a cache node. All right, so let's take a look at what client-side rendering looks like. So with client-side rendering, what we do is we have our chef in New York, and we have our person who wants to eat pizza in Australia. And when we render on the client, we send the chef to Australia. That's a lot, right? And then what the chef has to do is then the chef has to cook. And then at that point, you have delivered your pizza in Australia. But that's a little concerning, right? Maybe the person in Australia doesn't have a whole room with an oven for a chef to move in and start cooking. Maybe they have a flip phone that literally can't do that. And so this is a little bit of a complicated situation, all right? So of course, what do? Let's throw a cache on it. That should make it better, right? So instead, with our cache, all right, we send our chef to a basket, in the Pacific Ocean, right, the South Pacific, right? But we send the whole chef, right? And then we still have to send the whole chef to Australia, where they cook and they make their pizza. So again, we still have this situation, even with a cache. Sure, the chef is traveling from maybe a closer location, but they still have to go into that person's house and make that pizza. That's pretty invasive, I think. All right? So we can just keep sending those chefs, but yeah. So again, we have another option, right? We have server-side rendering. And of course, as everyone said, 10 years ago at JSConf EU, Ryan Dahl announced Node.js. And Node.js was super cool because it kind of promised to unify web development on both the client and the server. It was like, why are we doing this in 2 languages? Let's do it in 1, all right? And that made the server accessible to JavaScript developers. Maybe not for the first time, but certainly for the first time for anyone who didn't necessarily want to learn a new language. So let's take a look at what server-side rendering looks like. All right, so we got our chef in New York, and we've got our superhero in Australia. They're going to cook in New York. No more moving into the house to make pizza. And then they're going to send that right on over. Not bad, but that's a pretty long trip for some pizza, right? I'm not sure that's going to hold up. Fresh pizza is very important, all right? So maybe that's not the freshest of pizzas. So let's throw a cache on it, right? Cool, we'll throw a cache on it. So cool. The chef can still make their pizza in New York, and now they can just send it on over to that cache, and the pizza can hang out there, and then our Australia person can happily eat all the pizza they would like. But that pizza, maybe it's a little old. I don't know. What if they wanted an extra topping on something? They'd have to go all the way back, and that's really not efficient. And so when we talk about the client and server, and we've heard many other people talk about this at this conference already, is that we're seeing frameworks realize that they have to negotiate this boundary better. But that's really only just starting, and we're still genuinely talking about these trade-offs between the client and the server, and they're tricky trade-offs. Now, it wouldn't be an Ashley Williams talk if when I said trade-offs, I didn't immediately start talking about dialectics. Woo! Who here knows what a dialectic is? All right. Yeah, only the people who've seen me talk before, right? OK, dia what? All right, I'm going to try and go through this quick, but I think it's super important. So there's this idea of formal logic, right? Where you say A equals A, right? This is a thing, and then that thing is always equal to this thing. And we use this a lot in science. When we do this, we say, hey, when we reach a contradiction, maybe where A doesn't equal A, we are wrong, right? A does not equal A. However, I think that this is completely backwards. In fact, the dialectical method, in contrast to the method of formal logic, trains us to identify these contradictions and thereby get to the bottom of changes taking place. Fundamentally, the idea of dialectics is that the motor of history is these oppositions, and that resolving those oppositions and pushing them forward as the synthesis of the oppositions is what makes things happen. And I get so excited about this because I am a giant philosophy nerd. And so this is the philosophy nerd version of the diagram, but I think this one will probably go over a little bit better. Just wait for it. This is going to explain everything. There we go. Dialectics, right? And so what I want us to see here is that we've been kind of assuming this trade-off between client and server for a very long time, and that maybe that dichotomy is the problem. All right, so we've got this problem. Stuff is slow. We've got the client. We've got the server. They seem to be in opposition. We have no way to resolve them. What is to be done? So as I told you, I work for a big orange cloud, and this big orange cloud has a ton of baskets all over the earth. And so one day, they were like, hey, what should we do with all these baskets, right? We've been storing static assets in them, but maybe we could do something cooler. And yeah, this is a direct quote. Just kidding, it's not a direct quote at all. So what this became was like, we have the client and the server. Let's kind of take those oppositions, synthesize them, and create the edge. So let's take a look at what that looks like. We're back to pizza, all. I hope you were into it. All right, so with edge-side rendering, we have this basket, and we have the chef. And the chef just lives in the basket, right? And here's the thing. In all of our previous examples, no one could cook in the basket. But with edge-side rendering, you can cook in the basket. And so now the chef doesn't have to move into your house and make pizza. They can hang out in the basket that's near your house, make you pizza, and then deliver it to you. That's pretty sweet. But this kind of looks a lot like server-side rendering, a little bit, right? Like, it's just one. But the real trick is, remember, we don't just have one basket. We have a lot of baskets. And so, at any point in time, these chefs can be making pizza and sending them to people all over the world so everybody can have pizza that's nice and fresh without someone messing up their kitchen. And that's what the edge server in Cloudflare is. So you might be asking, this is a talk about performance. how fast are you, right? So benchmarks are dumb and bad, but I'm going to show you some. Your mileage may vary. These were done yesterday. Who knows what's going to happen tomorrow? But these are generally good representative benchmarks of what we have. So there's something called serverlessbenchmark.com, I think. But these are some competitive numbers. But I don't really want to do a product talk where I compete against other products. So I'm just going to kind of skip over that one. And I'm going to do what I call big numbers are big, small numbers are small, our numbers are small. So these are numbers for response times in Cape Town. And so a worker will respond in about 143 milliseconds. And just a GitHub pages page is going to respond in 591. In Doha, worker will respond in 44 milliseconds, and GitHub pages 497 milliseconds. What about Australia? All right, a worker, 208 milliseconds, GitHub pages 624. Those are some big numbers. And remember, these are people accessing the internet. Maybe you'll call me a millennial, but if I don't have access to the internet, I actually get nervous. So emotional health. But I mean, also, it's all of this information. All of the ability to prosper currently on Earth is largely driven by the internet. And so this access matters. Could you imagine having to wait that much more time just to get, I don't know, you probably read Reddit. You're Reddit. You would have to wait so long. It would be terrible. All right? Reykjavik, Iceland, even 34 milliseconds for a worker. GitHub pages, 170 milliseconds. So now you're probably asking me, how do you do that? That is very interesting, or hopefully you think it's interesting. And so let's talk a little bit about it. So we have all of these baskets, and it turns out that trying to cook pizza on these baskets actually has a lot of really fascinating constraints. And so the first thing we can think about is scalability. So for Cloudflare scalability, traffic or requests are super easy. Our network is huge. I think it can take over like 30 terabytes of traffic over it. It's a lot, and it's continuing to grow. However, for this model to work, this idea of tenants, or how many apps we can put in each one of those baskets, is super hard. Every app needs to be in every location for us, and some places are very small. So we're looking at a need for like around 100 times efficiency than what you usually see in like a server-side offering. And so we came up with a set of constraints. The first was for the code footprint, like the base amount of what the app needs to be. A VM requires 10 gigabytes. A container, around 100 millibytes. And then what we really needed was less than 1. Less than 1. That's a pretty big deal. All right, and then for memory usage, a VM is going to require at least 1 gig. A container, again, around the same that it had for the footprint. But we needed to do under 5. All right, and this is fundamentally because the edge is not a large place, or as I hear the kids call it, the edge is not thick at all. It's very small, and we have to get everyone's apps on here because we want everyone to be super fast, all right? Additionally, because of the needs that we have, context switching is a very interesting thing. So for a VM, very low context switching is needed. Maybe for a container, a little bit more, but like we need super, super high context switching. And this is because each of our servers only has to run, each of the apps only has to run the requests local to it. Right? So we don't need to be running that app all the time. We need to be able to switch back and forth between apps incredibly quickly, like to the point where like switching processes would be too much overhead. That's a pretty big constraint. All right? And so finally, startup time is a really fascinating constraint. A VM is probably going to take around 10 seconds, a container around 500 milliseconds. We need it to be less than someone will notice, around 1/50th of a blink of an eye. All right? And why do we need that? Well, if people start using too many resources on our edge, we need to be able to kick them out quick. But if they get another request in, we need to be able to start them back up quickly again in a way that the user would never notice. All right? So these are some pretty serious constraints, right? But there's other things that also have these same constraints. For example, certain APIs, particularly APIs that speak to other APIs, may need to run client code directly on the server because it needs to be more efficient. Similar with big data processing. With big data, you can't bring the data to the app. You bring the app to the data. And so it's very similar constraints to what we have. And then also, web browsers also have the exact same constraints. They need to be constantly running all of that code from all of those websites that you go to that all of you are writing. And this is where I say web browsers are freaking awesome. We have actually already solved this incredibly fascinating server-side need with a client-side technology. Like, server technology is actually too slow, and in building out server-side technology, have we just kind of overlooked the fact that we have this beautiful technology that's our client for the web? Browsers are optimized for exactly the types of things that we need in a type of serverless platform. They're great at small downloads. They've got fast startups. Someone's literally sitting there waiting for it, and so they're going to be moving quick. Remember, we talked about computation in the browser and how optimized and great it's been getting. All right? Additionally, I don't know about you, but I usually have around 100 tabs open at once, and so that's a heck of a lot of processes. But you also have to remember that a single page, all right, that is not always a single website. There's plenty of iframes. That Facebook like button is its own little context. And so the browser is orchestrating all of that. And then additionally, and I know that people are going to fight me on this, browsers are optimized for secure isolation. When you go to a website, if it was able to leak all of that stuff out to all of your other websites, we would be in a big, big problem. And so Kenton Varda, the architect of this runtime, has said, web browsers have been the most hostile security environment for quite some time. And I'm inclined to agree with him on this. I think that this makes sense. And so, with deciding what we were going to do for our serverless runtime, we picked V8. Come on. Oh, fine. Benedict Moyer loves the V8 joke. Gosh. He runs the V8 team. Anyways, so we chose to build our serverless runtime on V8, primarily using this idea of a class, a V8 isolate. Now, you could traditionally actually think of this more like a VM, but the word VM has kind of changed. And so this is more like a JVM, which is not quite the same. But you can understand it as kind of a lightweight context sandbox. And so why is this better than VMs or containers? And it's basically because you get to share more. It's like a little bit more communist, right? VMs, you get the hardware virtualized. And then you've got to bring everything else on your own. Containers, all right, you get the operating system. But again, bringing everything else on your own. With isolates, you get web platform APIs, the JS runtime, an operating system, hardware. And you just show up with your application and maybe a couple of weird libraries you wrote. And that's freaking awesome. And because we can share so much, we can very efficiently use resources. And so just to take a kind of look at what this is, in a virtual machine, you can see that the process overhead is one-to-one with the user code, whereas with the isolate model, you can see it's definitely many-to-one. And this is how we are getting those benchmarks that we are talking about. So in addition to using V8, we have built a coding environment for you that uses the fetch API and the service worker API. You can build it out in a UI that looks a little bit like this. You literally just have to have something that listens for fetch events, and then you can write a function that will handle requests. You can do plenty of other things, but this is like the bare minimum worker and what it looks like. Additionally, because we're using V8, we get WebAssembly for free. Heck yeah. So if JavaScript's not your jam, feel free to use a language that targets WebAssembly, and we can also use that. And so what you might be thinking, potentially, is, hey, this looks a lot like an operating system, and man, I would like to talk about how that's true, but I have literally no time left. So I would recommend that you check this out. If you want to learn about how we've tried to tame the killer, that's always really fun. But before I finish up, I do want to say, hey, is this a good idea? Right? Like, oh, cool, you can do it, but like, should you? And so a lot of people will be like, ah, yes, there is a Spectre haunting this architecture, right? Wrong talk, sorry. This one, Spectre. It is a fascinating memory bug. I unfortunately don't have time to go into explaining it, but what I will tell you is that we've made some mitigations to attempt to avoid it. Spectre is a bug that goes all the way down to the depths of the stack, and many of us are just trying to cope as you kind of pop up it. And so this is what we've been doing so far. Primarily, we're trying to avoid letting you have any sort of timer. So no date.now. If you use date.now in a worker, it will just tell you the same time every time. We also don't allow local concurrency, because that's a timer in disguise. But one of the things that we're also able to do is we also have the freedom to reschedule. We can take a look at someone who's kind of looking a little weird, a worker that's behaving funny, and we can just say, hey, let's kick you out, keep an eye on you, stick you in your own little box. So hopefully, I have encouraged you to think that this is a somewhat cool technology and that it's fast, and maybe you want to use it because you want to get fresh pizza to everybody in the world. But let's talk about how you can actually use it, because accessibility isn't just about receiving content, it's about being able to build content that other people can receive. And so I joined Cloudflare about 2 months ago, and just immediately it was like, oh shoot, we got to make this developer experience way better. People do not like curl commands with API keys in them. Like, that's not cool. All right? So you may have seen me on a couch yesterday, but I've been working on this tool called Wrangler. It was originally released for building Rust WebAssembly workers on Cloudflare, but is now a full-fledged CLI for uploading any type of worker you would like. I just found this picture of a crab with a cowboy hat on it. It's so good. You can npm install it, and it will just work for you. It looks a little bit like this. I couldn't speed this GIF up. Boom. So if you like emojis, there's a lot of them. But if your terminal doesn't support them, we have fallback. Additionally, we've set up a template gallery because maybe you don't know what you want to build with something like this. And so you can just generate one of these templates and get going with it. Each one will create an actual functional worker for you. And so that's pretty awesome. And so you can run this command and just publish, and it will be successfully published at this fascinating URL. How many people here signed up for a workers.dev subdomain? All right, we got like 3. So here's the thing. Remember that fucking DNS tweet? I hate setting up DNS. Maybe you do too. To get started playing with this kind of thing, you do not need to set up any sort of DNS. We will give you a free subdomain on workers.dev. You can get it by running the Wrangler subdomain command and snag that for you, and then you can just put all of the apps and workers you would like on it. So finally, we've got some cool new docs. The docs are also written as a worker, so dog fooding is good. And the big announcement here is, you probably are like, why do I care about this? Oh, this is a company, corporate product announcement. But today we're making it free. So I'm really excited because Cloudflare Workers are actually the first free edge serverless platform. You cannot put something on the edge, be it our edge or someone else's edge, without paying some money. And so I am super excited to get people playing in this brand new awesome spot, because I think it's really going to change how we think about building applications, particularly building applications as a more distributed thing across the world and not having to think about server and client. So we have a free tier. This is some stuff about it. Again, go forth and build. But I have one final message for you, because I'm not done, and I am almost certainly over time. But it's an Ashley talk, so we're going to go over, because I want us to do some thinking. Like, it's cool, this edge thing. Like, it's free, and like, I want you to go use it and like build awesome, accessible apps. But the real point of this talk is that I want people to think more radically, and with more people who don't look like us, about how the internet works and how it could work, right? When we encounter trade-offs, like the client and the server, I think a lot of people often are just like, that's how it is. That's what we have to do, right? Of course, we have the client server, we can't change that. But I want to encourage you to find oppositions like that and challenge them, because those oppositions are opportunities for making strides in accessibility for the web, like what we're doing today. And so again, we've talked about journeys, we've talked about performance, we've talked about accessibility. The web is the primary place that new developers go to learn, so let's make sure we can get there fast. The future where the JS community is representative of the whole world literally cannot come soon enough. Thanks.